Phasing is one frequency as it relates to another sound, the same frequency at a different time, and how they relate together. You need one as your baseline, and the second one to relate to it. Okay, so let's talk about the last thing. On the fifth week, we started talking about EQs. EQs, if you take a very short delay, I'm talking microseconds, you take a signal coming in, and you go ahead and you create a path that's not through the delay. And you can adjust how much or how little gets combined from both legs. This signal will come through and look exactly like the other one. This signal through the delay is going to come through and be delayed somewhat. When they add together here, you've got these two things adding together. One may be like this, the other may be like this. Add these together, you get this is 180 degrees out of phase. This positive, negative cancel each other, and you get 0. Or, if the delay happens to be short enough or long enough, this may end up being starting, instead of starting at 180 degrees, it may start here. And therefore, it will double its size. So you get twice the amplitude, or no amplitude, based upon how much gets combined and so on. This is the basic principle of how you get frequencies to get larger in amplitude or smaller in amplitude. That's the basic principle. It uses a very short delay. So let's talk about the different kinds of EQs. Passive, which is cut only, which we don't use very often except in, say, an electric guitar, where you cut high frequencies and this frequency is adjustable. It seems as if you're adding more high end when you don't cut as much. It's sort of a fake out, right? Because everything has to do with balance and relationships. But secondly, let's talk about our parametric EQ. Let's say we've got a 3-band parametric EQ. Low band, mid, high. You can either, this is called the peaking type of EQ. You can either add or subtract around a basic frequency. There's a peaking parametric. So you can, around the center line, you can either add or subtract specific frequencies. These frequencies can vary within the band. Then there's something called shelving. Shelving looks something like this. It's at the high end and the low end. So you either add and then it stays added all the way to the end of the spectrum, or subtract. And the same thing with the high frequencies, shelving. Because shelving really means that you add or subtract at a specific frequency and it stays at that level all the way out to its associated high end or low end. Let's talk about filters for a second. I consider filters part of a parametric EQ because they always come together, but they're more rightly called a filter. If this is frequency, high-pass filter looks like this because it allows the high frequencies to pass and reduces low frequencies. Low-pass filter looks like that. It allows the low frequencies to pass. I always got confused by that because it says low pass, meaning it reduces high frequencies. High pass means it reduces low frequencies. And if you put a high pass together with a low pass, you end up here with band pass, meaning one specific band can pass of frequencies. Now, one moment back to the parametric peaking, we talked about what a Q means. Q stands for quality. Q is the height over the width. Q of 1 means that it's as high peaking as it is wide. This is our bandwidth. Q below 1 means that it's wider than it peaks high. Q above 1 means that it peaks higher than it is wide. Quality meaning how specific is it to this one frequency that you have your EQ centered at. So quality, or Q higher than 1, really high, means it's very particular to that one frequency. Q lower than 1 means that it's not very specific at all, but it's generally centered around that frequency. Yeah, the bandwidth is from the highest point, if you lower down 3 decibels on both sides, where that is, and then you go down here and you subtract the higher frequency from the lower frequency, that gives you this distance, the bandwidth. The last thing about EQs, filters, and the like is a notch filter. Now the notch filter is very interesting because it really can be created from a parametric with a very high Q. So it looks like this, where it takes one specific frequency out. But that's specifically called a notch filter, and it's used to repair sounds that have some sort of resonance that you recorded that you don't like a tone in a drum maybe that's resonating too much, or some feedback that you don't like. It notches it out. It surgically finds a frequency and gets rid of it. And you can adjust how much you want to do or where this frequency is, right? The two uses of EQ, first use of EQ is to correct a bad recording, right? Corrective, to try to make it sound more like it was meant to be when it was recorded because of poor recording techniques. The second use of an EQ is to create an effect.